Hi everyone. Let us solve a Pytorch implementation question called non-management suppression or NMS. So NMS is a frequently used technique of object detection to remove out useless bounding box so we can save the computation efficiency in later stages, such as calculating the mean average precision. Let's illustrate how NMS works using drawing here. Let's say we have three bounding boxes for same object. Let's say the first bounding box is here, and maybe the second bounding box is here, and maybe the last bounding box is here. I use graph drawing here. Okay. The first thing, we want to assign the bounding box with the name and the confidence score. So let's say the first bounding box is B1 with confidence score 0.8. And second, the bounding box, this bounding box is B2 with confidence score 0.9. And finally, we have this B3. So let's assign the, for example, the confidence score 0.7. Okay, now finish that. Well, for MS, we use two conditions to fill out the useless bounding box. Let me write it out here. So the first condition is that the two bounding box should have the same class. Okay, otherwise, it doesn't make sense to do the filtering at the same class. And the second thing is that the IOU score between two bounding boxes, let's say BB box 1 and BB box 2, will be greater than the IOU threshold. So this means these two bounding boxes are close enough, and it really makes sense to work on this closely related bounding box if 1 and 2 both hold. Okay, if 1 and 2 are true. Then we want to only keep the bounding box with largest probability score. Okay, now finish the condition for checking non-maximum suppression. Let's take this example here. So let's say the IOU between this B1 and B2. So I write it out here. Let's say the IOU between B1 and B2 is 0.7, and let's say the IOU threshold will have initialized at 0.6. If that's the case, we find okay, 0.7 is greater than 0.6, so this condition holds, right? And since we have both the red color, meaning B1 and B2 had the same class, the condition 1 also holds. So if both 1 and 2 are true, we want to keep the bounding box with large probability and discard the other bounding box. So we want to keep the bounding box, this bounding box, because it has largest probability. I want to remove this bounding box with smaller probability. Okay. So just remove this bounding box. And the next step is to check between B2 and B3, right? Because we haven't checked the B3 yet. And then we'll calculate IOU between B2 and B3. So for example, let's say the IOU between this one is 0.5, because you see the interaction between these two is very small, right? I found 0.5 is smaller than 0.6, right? Okay, if that's the case, the second condition does not hold, and we cannot remove the bounding box with smaller probability score, and we have to keep both bounding box, to keep both B2 and B3. Therefore, the results element after MS will be B2 and B3. So you see B1 is removed, but B2 and B3 is kept. Okay, I think the intuition and my drawing will make some sense to help you understand. Now let's dive into the coding part. Okay. So first thing is to get the valid bounding box. We're getting the valid bounding box, and after that we'll sort those bounding box by probability score from largest to smallest. So we already have the bounding box with largest probability score at the top. And after that, we want to initialize the result array and run a while loop. And what to do in this while loop? Well, we'll keep pop the leading element in bounding box, which is the bounding box with the largest probability score, right? And now we want to do the filter with this leading bounding box. So how can we do the filtering? If found the score is smaller than average threshold, or the bounding box had different or a different class with the leading bounding box, then we have to keep it instead of discarding this, right? So our different class, then we have to keep it. And after that, we want to update our bounding box, and finally we return the result. Now finish coding comments. Let's write the code itself. So first, the bounding box. We have this bounding box, right? So I want to check all boxes in these bounding boxes, and if this bounding box has score greater than the lowest probability threshold. Okay, you see the second element is probability score. If probability score is greater than the probability threshold, then we want to keep the box, and otherwise we discard the box. Okay, now get the valid box according to the probability score. The next thing is sort the bounding box using the probability score, right? So let's use the sort function in Python here and pass in this variable. And since we are sorting according to probability, let's write the key using lambda and x1, right? So I'm passing probability as the key for sorting. And we want to sort from largest to smallest, so we want to set reverse equal to true. We now have finished bounding box sorting. The next thing to initialize the result array. Let's say it's a bounding box with NMS, the empty result array, right? And while there's still bounding box in this array, we want to keep run this while loop. And the first thing in the while loop, as I said before, it pops the bounding box with the largest probability score. So let's say it's the lead box. We call it the lead box. And using the pop operation, so pop the 0, so I'm getting the first element, right? And then we want to check which bounding box we have to keep. So to check all the boxes in these bounding boxes, box in bounding box, if the class are different. So if box 0 is not the lead box 0, this means this box had different categories with the leading box, right? Or we found the average threshold. You see the intersection of the linear function right before. So we just are passing this function, and we pass the leader box here in the first element. I want to pass this box here, the second element. But note here we had changed the 0 to 2 all the way to the end. So why did we do that? You see the first parameter here is class, and second parameter here is probability. And if we're starting at 2 from all the way to the end, we are getting the coordinates instead of the class and probabilities. And the other thing to do, since this function receives the Python tensor, we want to convert this array to Python tensors using a torch then tensor function. Okay, so let's change it here. Now fish in IOU score. If the IOU score is smaller than our threshold, then we want to keep it, right? Okay, now finish the sorting the bounding box, which we want to keep. The next thing to when you update the bounding box after non-maximum suppression, we'll append all those lead box to this array, and we'll return this bounding box of MMS. Now let's run the code to see it works. Okay, you see it works, right? We have the test case here. So for the test case, we have 3 bounding boxes for class 0, and we have 2 bounding boxes for class 1. And you see for 0, we run non-maximum suppression, and only this element is kept, right? And for bounding box with class 1, we run non-maximum suppression, and only this elements is kept. The result array consists of 2 elements. One is this, and one is this.